Assalamualaikum and salam sejahtera. Our topic today is on active filter. What is the difference between active filter and passive filter? The difference is active filter employ operational amplifier in the circuit, while passive filter only has simple resistor and capacitor. By employing operational amplifier, the circuit now will require external power supply in order to work. Therefore, now the circuit has becoming active circuit. So that's why the active filter got named from. The advantage of active filter is that the circuit able to function as a filter and at the same time able to provide amplification. If you notice in simple filter, either in high pass filter or low pass filter, the maximum gain is only 1. But in active filter, we will be able to design the gain to be more than 1. This is the circuit for active low pass filter. If you notice here, there is operational amplifier in the circuit. So we have two resistor, R1, R feedback, and one capacitor, capacitance feedback. And the voltage input is connected to the negative terminal, while the positive terminal is grounded. As for the derivation, we always consider that I current here equal to 0. Summation of the current to the operational amplifier is equal to 0. Therefore, we have I1 plus I2 plus I3 equal to 0. So from the equation, we have I1 equal to minus I2 minus I3. So I1 is V in over R1, I2 is V out over RF, and I3 is CSV out, or sometimes we write I3 is CDV, or equivalent to CSV out. Okay, so by solving this V out, V in over V out, we get this equation. V out equal to minus RF over R1 is the amplification part, which is the gain, multiply with this part here is the filter part, filter effect part. It will act as a filter on this part. If you compare with the equation for RC low pass filter, it has the same equation for the filter part, but without the gain part here. Using the last equation, we're going to replace S term with S equal to J omega. The step is the same as the step when we derive for RC low pass filter. Then we're going to find the filter gain or the magnitude of the equation, which is the ratio of voltage output over voltage input. So we get this equation where the magnitude is RF over R1, 1 over 1 plus CF RF omega. So the S term now has been replaced with omega term. So meaning we can find whatever gain for the filter by replacing omega value here for a specific design of CF and RF. Notice that omega here also can be replaced by frequency, because omega is in radian per second, while F is in hertz. So then we also know that the characteristic behavior of a filter is based on the cutoff frequency. So whether it is in radian per second, 1 over RF CF, or in terms of hertz, 1 over 2 pi RF CF. So by putting the cutoff frequency into the gain equation, so we get the new gain equation in terms of frequency ratio form, which is this equation here. You may notice omega per omega C here, or you can use F per FC here. As a summary, this is the circuit for active low pass filter. Please make sure you know how to draw this circuit. As for transfer function, there are three equations that can be used. The first equation is the gain equation at any frequency. Second equation in form of frequency ratio omega per omega c. And the third equation in terms of frequency ratio F per Fc. Please take note that this equation has two parts, which the first part is the overall gain filter, G not equal to Rf over R1, or this part here. And for the second part, this is the filtering part, and the cutoff frequency can be calculated as this equation. This is in radian per second, and this is in hertz. Okay, if we look at the response of active low pass filter, it has the same shape as RC low pass filter, where before we said that at this point here it will give us gain 0.707. Please take note that this value is when the overall gain is 1. But if the overall gain is 2, if you design Rf over R1 equal to 2, then the value here must be multiplied with 2, which will give you 1.414. In terms of decibel, if you multiply 20 log gain at 0.07, it gives you negative 3 dB. But if you multiply with 2, when overall gain is 2, it is 1.414, which gives you positive 3 decibel.